Okay, so we're going to continue with the all conversion possibilities. And I rewrote this diagram, the map of the conversion from particles to moles to atomic mass, molar mass, and the mass. Even on the other side, on the right hand side, moles and volume, as well as then using Avogadro's number, as well as the Avogadro's hypotheses for the volume, molar volume, 22.4 liter per mole. Okay, first question. It has nothing to do with any of this. I just want to make sure that you guys understand what this question is, because it's going to show up again and again. But it's a very basic one from science 10, maybe 9. How many atoms are in 4 molecules of copper sulfide pentahydrate? This is number of atoms, and I want to make sure that you know how to answer that. So we're going to go through each one of these. So how many copper atom do we have? We have one copper atom. We have one sulfur atom. We have, in this case, we have 4 oxygen on this side, right? And then we have the hydrate, the penta. 5 times 2, that's 10 hydrogen. And we also have 5 oxygen. Okay, that 5 includes that too. Now you're going to add them all up in here. You get 21. That's what I got. I got 21 atoms. Okay. Now this is for one molecule, but there are 4. So we can now set it up. 4 molecules of that multiply by, we're going to do the molecules in the denominator. 1 molecule of that, we have 21 atoms, right? So if that's the case, you're going to multiply 4 molecule times 21. Molecules are molecules, they divide, and then you're going to get 4 times 21, which is 84 atoms. Okay, so that's how you answer that question. Very simple. All right, very good. Now let's go to the next question now, using this pathway, the basically the calculation map to find all other conversions. Okay, here's the second question. What is the mass of 125 helium atoms? We're going to go from number of atoms to mass. But to do that, we're going to use the mole. We're going to get to the number of moles, and then we're going to go to the mass. Okay, so let's do that. We have 125 helium atoms times. Now we have number of atoms down here because we have to get rid of that, and that's 1 mole. Well, 1 mole, how many atoms? That's Avogadro number times 10 to the 23, and multiply that by mole in the denominator, 1 mole. And what is the molar mass of helium? Molar mass is 4.0 gram, right? So we can put 4.0 gram on top. Very nice. Now that we have this, we go ahead and simplify. Atom divided by atom goes away. Mole and mole will go away technically. And then we have the gram left, and it's what's the mass of the 125 helium. And the answer to that, 8.3 times 10 to the negative 22. Okay? Very small. Very nice. Let's look at another question. Here's another one. What is the mass of 3.45 milliliter of oxygen O2 at STP? Okay, well, here what we have is we are going from the volume and we want the mass. But to do that, we're going to bypass it to get to the mole using the molar volume, and then from moles we can get to the mass. Now we have to check that the volume that we're dealing with here is milliliter, but at STP, we have the 22.4 liter at STP. That's per mole, right? So we're using liter here, but we have milliliter ml there. So we have to change that as well. So we're going to start with the conversion right away. So 3.45 milliliter times, we do the milliliter in the denominator, liter on top. 1 liter is 1000 milliliter. That's a prefix for the unit conversion. Just remember that, right? And then once we have the volume, you say, okay, liter on the bottom. And now we can go with mole, right? 1 mole on top. So 1 mole 22.4 liter. And now we're going to change the mole to the gram because we need the mass. So mole in the denominator and then gram on top. 1 mole O2, that's oxygen, right? Oxygen has 16 times 2 is 32 grams. That's the molar mass of O2, 32.0 gram. And now that you have this, you just have to multiply through and realize that all the units are being divided that we don't need. Milliliter and milliliter cancels out. We have liter and liter goes away. We have mole and mole. And at the end, what we have is multiplying the top divided by bottom. And then we get the final answer. The mass is 4.93 times 10 to the negative 3 gram. That's the mass of the 3.45 milliliter of O2 at STP. This one, how many atoms are in 1 mole of NH₄Cl? This is ammonium chloride. What we have, we want to go from mole to number of atoms. Okay, so let's set that up. We have 1 mole times, and here's the thing, mole in the denominator again. Now, number of particles or atoms on top, in this case will be number of molecules, Avogadro number, times, and then molecules in the denominator, and atoms on top. Okay, so that's 1 mole, and that's many. And then in 1 molecule of this, how many atoms do we have? How many atoms? Well, we have 1 nitrogen, 4 hydrogen, and 1 chlorine. That's 6. That's perfect. Now we're going to go ahead and multiply the top. And once we do that, it's just basically 6 times the Avogadro number. And that answer will be 3.61 times 10 to the 24 atoms. That's number of atoms in 1 mole of this compound. Excellent. So here's the last question. What is the volume of 16.5 gram of AsH₃? This is arson. And it's gas, it is poisonous, it's deadly at STP. All right, let's go through that. Well, this is very simple. We're going to go from the mass to volume. Okay, and we're going to start with 16.5 gram times, we're going to do the gram in the bottom, mole on top, 1 mole, and AsH₃ has a molar mass of 77.9 gram. Okay, you can use the periodic table to figure it out. That's 77.9 gram, and then times mole in the denominator, 1 mole, and that's 22.4 liter on top. Simple as that. All right, and then we're going to go through it. Gram divided by gram, and then mole divided by mole. Whatever is left is the liter. And that's simply, when you multiply everything together, you get 4.74. So here's the last question. What is the volume of 8.65 times 10 to the 21 molecules of sulfur dioxide gas? Okay, so let's go through that now. So we want to have the volume, and to do that, we start with the number of molecules, 8.65 times 10 to the 21 times, and then we have molecules in the denominator, and mole on top, and this is the Avogadro numbers again, so that is 23, and then we want the volume, and that's 1 mole, and that's 22.4 liters for the molar volume. Excellent. Now we're just going to go through and then divide, and whatever you have is the liters that is left, and the final answer in here will be 0.322 liters. I'm going to leave it at 3 decimal places because of the, and 3 sig fig because of the 8.65 as a practice. All right, that's the last question I want to talk about. Make sure you take the quiz that is in the description below and a pinned comment. Check out the next video in this series. All right, until next time.